Hello everyone. Today our topic is about metals and non-metals. Yeah, as we all know about metals and even non-metals, metals are iron, which like most of the metals we used in construction business, construction buildings and aircrafts, automobiles, kitchen utilities, applications, surgical, like most of the metals which they use for daily purpose, and even not only metal, even non-metals like plastics, um, glass or thing, like most of the things even we use even non-metals also, like it is a very essential for human using products like metals and non-metals. Well, today we can learn a bit more about metals and non-metals, and way it isn't even easy to learn. And metals can be classified as ferrous and non-ferrous metals, and non-metals can be classified as organic, which is plastics and ceramic materials, glass, and other one is composite materials. Well, general metals are classified into two types. As we all know that there are ferrous and non-ferrous, and other one is non-metals, and the other one is non-metals, which is classified in as organic, plastics and ceramics materials. Third one is composite materials. Yeah, metals are divided into two types. One is ferrous and other one is non-ferrous. It contains ferrous generally contains about iron. Almost all are magnetic. For example, mild steel and cast iron and tool steel, etc. Whereas even non-ferrous, they do not contain iron. Like non-ferrous is quite opposite to ferrous. An example, even aluminium, copper, silver, gold, lead, tin. Yeah, of course we are saying that ferrous is in magnetic, whereas non-ferrous is non-magnetic, quite opposite to it. And even alloys, a mixture of metals or an metal and small amount of other substance, like mixture of metals, a group of metals combined together, like which we call it as a alloy. Not even a group of metal, at least even a small substance which they group, it's an identical of an metals that we can call as an alloy. A group of metals is called alloy. Okay, and even a small substance. Even the alloy is also divided into two types. One is ferrous alloys, other one is non-ferrous alloys. Ferrous alloys, for example, stainless steel, steel plus chromium, and non-ferrous alloys, brass, copper plus zinc, and bronze, copper plus tin. If if we if we look at this picture, like we can know about brass, like how it looks in this picture, even bronze over here, and metal such over here, and steel. See, even copper is like more visible, and even cast iron, even aluminium metal. There are some kind of metals which we can look in this picture. In this picture, like all together, even one, two, three, four, five. There are seven metals of different. Even this brass contains of alloy non-ferrous, even bronze and metallic steel and copper. Yeah, and the next one is metallurgy, the art and science of existing metals from its ores. From their ores, types of metallurgy, and there are four types of metallurgy: physical metallurgy and extraction metallurgy and mechanical metallurgy and electrometallurgy. And whereas these metallurgies, the first primary thing in physical metallurgy, the study of alloy or metal properties, and extraction of metallurgy, the new metals extraction from its ores. And mechanical metallurgy deals with shaping, working of metals, casting, welding, jointing, and forging, rolling. And the last one, electrometallurgy, deals with the electrolysis process. These are the basic steps for an types of there are some types of metallurgy. That there are four. One is physical and extraction mechanical and electrometallurgy. And the next one is the properties of the materials. There are physical property and technological properties. The physical properties like shape, size, and color, and specific gravity and structure of the metal or alloy and surface, then finishing. Like these are the steps that which we observe when we look at a material, like shape and size and color, and in the gravity and structure of its other technological properties. And there are machinability and weldability and formability and workability and castability. Like these all are the properties of material. Like if we can observe here, like the machinability, the picture over here, see the process which is being done over here, and even sending the metal into it. Whereas you can see here sending with speed the tool which is over here, and rotating the speed 10 centimeter, and the material which is placed, and the chuck in sequence, and cutting depth over here, and the sending speed. We can look in this. Like even weldability, it is a basic thing of a basic arc of a welding machine. Like you can look at here welding machine, like where the specimen is placed over here with the arc, and we can see its work, whereas the specimen is placed here on the surface, and the electrode rotor is acting on it, electrolyte. Whereas these are the other pictures of the weldability, and where they welded in this process. The process is done in this manner. And the other one is formability. Like we can look at this picture of the thickness and even the bent radius, the specimen, and the laminated stress over the. In this picture you can see even the forces here, and the punch, and a blank holder over here, and shear B and shear A is acting on that. So shear B is acting on this side for the formability, and we can look in this picture. And the next process is castability, and you can look over here how the process is done, the castability, and kind of an images, pictures that you can see here. And the next is workability, whereas you can look like how the workability is done in these pictures. Like on the first picture, and the man over here is rating. Even the second, you can see inside the machine what is going within it, and the third, the process, how it the carrying the way. At last they're finishing in workability. There are even more properties like thermal properties and electrical properties and chemical properties. Thermal properties, thermal conductivity, thermal expansion, thermal shocks and thermal stresses, and electrical properties of conductivity and resistivity, and chemical properties of an atomic weight, corrosion or acidity, alkalinity, and chemical composition. Like these all properties which include for a specimen or a metal or alloy to know whether how much the corrosion, how much the thermal stress, how much the conductivity, how much the weight of an atom, or thermal stress or the shocks which they are acting on a specific metal. Like these all properties are very beneficial to bring out the strong metal. That whereas to know like these properties that which we put into, which we put on the metal. And whereas you can look here mechanical properties, the elasticity and plasticity and ductility and malleability and brittleness, hardness, stiffness, and reciprocate creep, strength, fracture, and means. Well, the elasticity we can know extends and returns of the original the position, where the elasticity and plasticity is the permanent deformation of the original picture or original the way you look from the beginning. Like the plasticity which completely deform into the other shape, and ductility the of thin wires, and malleability of a thin sheets, and brittleness sudden fractures over the on the metal, and the hardness which resists against the harder bodies, and whether it can stoppable which any or a huge load which it can act upon the metal or not, and toughness maximum energy of the fracture, and the stiffness is resist deformation, and resistible strokes energy and resist the shocks, and transforms creep, it deforms continuously under a steady load, continuously in a steady load, then we can have the creep and injury, and withstand varying of a load strength, and withstand the load without any fracture, and protect and material are fractured by means and progressive brittle and cracking under repeated of alternating or cyclic process. Thank you.